early morning for you, or you usually start at 6 in Yerevan? What? Usually start at 10. Now, I was wondering because the whole understanding they have breakfast which starts at 9, which is like, oh. In the US, we just start at 6 or something like that with the breakfast. So I said, well, that's maybe a pretty early start. So anyway, thank you for dragging yourself out of bed and coming here such an early morning. Yes, and that, am I all ready for us to start?
Yes.
Okay, cool. So, let us get going. Pull out my slide here. Okay, first I wanted to say thank you guys. I really appreciate your wonderful city here. It's Yerevan. Also had a chance to go explore some surroundings. I went to your highest mountain yesterday with some friends, right? And you can see one of my, I would say, like a passion project is I run this little community called Geeks Go Peaks, trying to get the engineers up from their butts and explore nature. So you can see just a few of us. So I may be only moderately successful in this trip here. Also, I want to thank all our organizers and partners. In particular, Emma, which is so here because making those events usually takes a lot of local logistics, finding a venue and so on and so forth. Oops. And it can be, tricky without having anybody on site. You can maybe want to put it closer to the wall so when it wants to lean, it has something to lean on. With that, I wanted also to get a couple of practical questions out of the way. First, when I have those events, sometimes people ask me, well, Peter, you're from Percona, and there is something I want to discuss about your product, services, what you offer. I am not really in sales, I stay away from that. And if you guys want to talk to Percona sales directly, who is responsible for your region, here is the person I wanted to show his face. The second one, which I often hear say, well, it's just kind of like a cool free event, so I appreciate you guys building the community. How do you organize those events? And in many cases, it is really based on the local interest, right? If there is somebody in the city like Emma who says, hey, you know what, I'm really excited about building a local community, you often can come into our city as well. If you are interested in that, then let us know. And the third logistical item is about jobs. People also ask me about jobs as Percona, and again, as a sales, I am not particularly too much involved in that at this point, but you can check out our career website. We have a bunch of positions we are always hiring for. And with that, let me switch to their main point of my presentation and talk about the open source databases. Anybody here runs any open source databases? Oh, look at that. A few hands. Well, then you're in the right place, I guess. So, when you talk about open source databases, I wanted to talk about two different angles about that. First, to talk a little bit about innovation, which is going on in the space for the last few years. One thing I think which is exciting, which has been going on recently, is a lot of focus what we see on distributed databases. I mean, if you think by now some of the most popular databases, such as MySQL, Postgres, they are not really designed to distribute, right? We kind of try to maybe do something on top of them, but they have been designed for really kind of single node from the initial design. But that, of course, also happened decades ago. If you look at something which is kind of more being designed in those days, it almost always comes in it's distributed kind of by default, or at least from very early versions. Like we have a few talks about ClickHouse, for example. Well, that is, engine which is very commonly run in a distributed way. And that is a very big trend. What you see, a lot of newly designed systems are being designed for the distributed work in the cloud. The second interesting technology trend, what we see is called separation of storage and compute. Again, if you look at the classical databases, such as MySQL, Postgres, it's kind of designed where you have this sort of processor node which works with a disk, and that disk is locally assigned to that node. If you want to scale that some way, you have to sort of increase the number of nodes, all of which have a storage and compute, and you kind of have to scale storage and compute together. And that, of course, worked very well for architectures in the past. But now, if you are looking what the cloud offers us, we also have distributed storage, S3 in Amazon, and a bunch of others, pretty much any cloud provider. And that storage is kind of cool if you think about the database standpoint, right? Because it is very scalable. It's also not something you need to really, provision like disk, like I provisioning 10 terabytes, and if I need more, I have to do something to get more, right? It's sort of bottomless. And also it is, in the cloud in particular, is cheap, much cheaper than disk. So there's a lot of interest to that kind of storage. And a lot of databases, starting from analytical databases, now they have a lot of specialized databases for logs, for time series. They increasingly use that separation and storage and compute. But that also comes to their relational database as well. So one of the companies in PostgreSQL space called Neon. Anybody heard about Neon? Yeah. So it was recently sold to Databricks, right? They have been bringing that exactly separation of storage and compute to Postgres as a replication. Now, what is also interesting thing, what the storage and compute enables, is this concept of serverless, right? Well, of course, serverless, a particular database, is kind of misnomer, right? Because the database itself is still run on some sort of server, right? Everything kind of runs on some kind of server really. But what serverless kind of concept tells us about is what, as a user of a database, developer of a database, you are not being tasked anymore to provide provision the database node or nodes. You just say, hey, I need so much of a database capacity, right? And think about it in this terms, right? Which is rather convenient in a lot of cases. What also serverless allows us to do is to really on very small use cases. Let's say you're building an application for personal use, you kind of just use it 2 times a day to say, hey, a database is going to be actually non-operational now and also kind of awake, then the request comes in. That allows to build very cost-effective infrastructures. The next trend, which is interesting, what you see kind of going up and down. I don't think what it's kind of being used so much recently, but it's actually still being utilized in a lot of databases. This kind of idea of hybrid transactional analytical processing. So, hey guys, I want a database which I want to run my analytical queries on the same database as I do for my transactions. And that's very useful, especially for live analytics or logs, right? Because, well, why would I want to provision You can see this done by Amazon, right, in their kind of RDS fork, right, but also solutions like TiDB, right, which have some, seamless ClickHouse-based code integration, which allows you to use one database in a case. This works in a certain environment, but I think what you also find out is what saying, hey, I just have one database, and it's used by a whole bunch of teams for everything. That gets complicated. Often kind of organizationally complicated, right? And you can say, well, my analytical team or something, put a lot of reports on the database today, it got overloaded, so my normal traffic doesn't work. And that is where we see an alternative design, kind of something like data pipelines, enterprise data bus, there's different terms of that, but we can say, well, you know what, we are going to get the data which you're going to replicate in a different storages, which are all purpose built. Maybe this one is done for full text search, this is for analytical, this is how we use, to do our AI models, this one is used for transactional, and that is where technologies like Kafka, and there's like a lot of similar variants coming up to the market right now used for this technology. The next technological trend, what we see is many companies use multiple databases, not just one, right? I remember probably like 20 years ago right now, right? You would come to the people and say, oh, we are Oracle shop, or we are Microsoft SQL Server shop, right? Or something. It's often would be just one database. If you look large organizations right now, a lot of them would use large number of databases. As well, maybe more than 10. And there are a few reasons for that. One is, of course, there has been a trend of microservices, right? And the concept of that is I design my service, and it's kind of encapsulate the data, and then the team can choose what kind of storage to use, which is the best for me to that microservice, right? Obviously, different teams can use different choices. The other one, of course, is development effort, right? Or developers effort, right? Sorry. So the idea here is, if you look at a while ago, there would be some database team which would design, oh, we only are able to support this database or this couple of databases. Now, often it's reversed. You can see the developers which are going to pick the database which they want, which can say, hey, that is how we can build the application faster, and then maybe they're going to support it, maybe it's kind of going to support the other team in the organization, but the choice is theirs. And the third one is the cloud. By the way, how big is the cloud here in Armenia? Do you guys run in the cloud? Anyone? What about on-prem? And what about the rest? You guys don't run your database anywhere? Okay. I understand. Early morning, everybody's kind of still catching up on their sleep. But anyway, what happens in the cloud? The cloud is interesting because they offer you what's called fully managed databases. Well, it's maybe not completely fully managed, but the reality is cloud makes you get to the databases easier, and that becomes very seductive for developers to try and experiment with different stuff, right? They can just get the database, I deploy it in the cloud in a couple of weeks, and it kind of runs itself. I don't have to figure out how to provision that, and that, of course, encourages a lot more of an easy experimentation again, gets us more database use. The other interesting thing what has been happening is we have a lot of different models those days, right? I remember when I was starting to be involved with the databases, it was kind of an age that was relational was kind of everything, right? The relational database, that's it. Now we have document databases, key value store, we have time series, we have all kind of specialized graph databases, right? A lot of different models being experimented with. And I think what is also interesting is what we also see that this idea of a single database does not have to be only one model, or only speak one language, right? We can see many databases and say, hey, we can be your relational database, but we can also be your document database, or used for key value or for full text search, right? Like values becomes very common, and also even talk different languages in the protocols, right? I think that is often utilized as a growth hack, if you will. Like what ClickHouse did, for example, saying, hey, you know what? Of course, we have this kind of awesome ClickHouse protocol, but you know what? You can connect to ClickHouse as it is very MySQL or Postgres. Right now, we have also, I think, releasing the support for Prometheus protocol, saying, hey, you know what? We want to make it easy for you. We don't want you to deploy this kind of a new connectors to application, use all of the things like we want to make it easy. And ClickHouse is not alone. The next one to cover, which also has been big in the last few years, is vector search. Anybody heard the term vector search? Okay. Quite a few have been. And this is technology in a database which supports building applications which use AI. And AI is kind of big those days, right? Now, you may ask, okay, well, we talk about like AI. We understand, like, I go to ChatGPT, I ask a question, and it gives me some wonderful response. What the hell does it have to do with vectors? Right? Why do we talk about vector search, right? Well, and the reality is, of course, on the top it may be something like a chat or image generation, right? Or something else. Underneath, there is really a lot of math providing that functionality for you. And a lot of that is math based on matrices and vectors, right? Specifically when it comes to the databases, right, we often have a vector-based functionality where you will see the sort of like real-world objects being converted to their mathematical representation, which is essentially a vector, right, often called embedding. And when it comes to the databases, right, if you look at the very core of what relational databases do on the low level, right, they are pretty much based on the BT indices, right? They can find the matching values, they can find the values which is kind of like between two different values. That is essentially the core, and all that kind of good stuff, SQL language, right, there are general optimizers based around that. Not only that, but that is like a pretty much core. Where you see in the vector search, it is about finding similar vectors, right? And that is what your classical database with BT indices are not really designed very well for. That is why you need that kind of special purpose extensions like PGVector, right, or specially purpose built databases. And in fact, you can do like a whole bunch of different features that you can support that, pattern recognition, semantic search, travel augmented generation, all that stuff is sort of like built around that vector search. Now, if you look at vector search, it's also very interesting because of when it became supported in different database engines. And you can see, well, roughly 5 years ago, before 2019, that was not really a thing, right? Didn't exist anywhere, and now it exists in very vast variety of database technologies. I would say the MySQL has been kind of unfortunate and only exception among the major databases. Well, and in that case, because Oracle decided they want to keep that only in the cloud version so far, right? So while there's some third-party implementation that works exist, there is no official implementation for that. If you're looking for full text search in MySQL, MariaDB actually was quick to say, hey, if Oracle doesn't want to do it, we can do that in MariaDB, kind of provide you sort of their better MySQL on this dimension if you really unload it for it. Okay, with that, I want to talk more about the open source side of things. Now, if you think about the open source, what do you think like the big kind of factor which impacts open source those days? Any thoughts? What impacts open source now?
Basically, it's open and it's very complicated, which you work for many startups and
Okay.
While licensing, actually, it's really started for open source.
Licensing, okay.
Funding for computers.
What is it?
Funding for the computers.
Funding for computers. Oh yeah, thank you for having that. Well, look, what I think it's interesting, if you look about like funding for contributors, right, for example, that also has existed kind of for years, right? And almost kind of a pretty long, multi-decades journey to open source right now. Now, what I think if you look at the cause of a lot of those changes from my standpoint, that would be the cloud, right? Because if you think about a lot of the open source movement projects that were kind of born before the cloud was big, right? And it wasn't kind of expecting or they will, hypercloud, it's sort of like a package open source, make all the money, right? And hey, what to do about that? And I think the cloud impact to open source, in my opinion, is very different, right? Because on one standpoint, the cloud really allows to simplify a lot of things, right? And can really maximize adoption. On the other, cloud vendors kind of want to ensure they are getting a big chunk of that money which comes from that adoption and so on and so forth, right? And this is where you can see often different companies can look at that rather differently. So if you think about PostgreSQL community, right? It overall looks pretty positively on the cloud, right? I would say why did really Postgres became this kind of most really fastest growing open source database those days. And a lot of that actually has originated from a cloud, in my opinion, because PostgreSQL was often something like developers would love, that would be a bitch to operate. And therefore, some smart engineers say, what is the problem, right? I spin up this, like a patronium, and figure out all those kind of bells and whistles, and it's fine, A week later, have this wonderfully running PostgreSQL cluster, right? But for a lot of engineers who don't have that skills, a lot of developers, that was the part. In the cloud, you don't have to think about that. All that kind of complexity, how replication works, how ability works, is kind of hidden from you, right? So that it was really, really good for adoption. And what also happens, if you will, a lot of PostgreSQL engineers right now work for Amazon, Microsoft hired a lot of them. So yes, it's no more just guys like Enterprise DB anymore. A lot of them moved, and a lot of support comes from cloud vendors anymore. But from community standpoint, it is not that. There's still a lot of engineering going in PostgreSQL ecosystem, now just funded by different people. Now, if you look at the other kind of open source or original open source like MongoDB, you can say, oh, clouds are kind of trying to run MongoDB. They're not going to let them. They want only MongoDB to make money on MongoDB in the cloud. Well, so they'll change the license to non-open source license. So they have been really seen that as a threat, right? So I think that is very interesting to understand that. Well, anyway, one thing phrase I like, and maybe because Martin Nichols was their CEO when I worked with MySQL. I know what I was like early 20s, very impressionable, right? You tend to remember stuff better at that time, right? And he used to say, what guys remember, what their open source is not a business model. Open source can support multiple business models, and it also doesn't really require one. Right? You can just say, hey, I'm maintaining this kind of project as a hobby. I just, love, I don't know, let's say, have this open source tool for astronomy. I don't need a business model around that. Open source doesn't require it. It doesn't dictate it, right? And different business models may work for different open source at different time, different circumstances. Now, when we talk about the open source, we often focus on open source, which is a license, right? While I think what is very important is also to thinking about the ownership and governance. The two examples I brought, MongoDB and Postgres, are very different in this regard. Because if you think about that, the PostgreSQL is kind of the quintessential of their sort of community project. It's not owned by any particular single vendor, right? And it has also that kind of, governed again by the community. I wouldn't say PostgreSQL governance is perfect, right? Well, probably not. Or it is, but it's not driven by a single vendor. Like, hey, it's only does what Amazon decides, right? Or something else, right? And then there are, of course, a single vendor owned open source, right? Like, you could see MySQL, owned by Oracle, still open source. MongoDB was open source, no more. And then there's guys like Elastic who's played this there and that game, right? Oh, we don't think open source is a good idea, but then, well, you know what? Now maybe we think it's due, right? So this is a kind of example of a single vendor owned open source. Now, if you think about like a multi-vendor on a foundation-based open source, they generally say, hey, you know what? Cloud is wonderful. It helps us with adoption. It changes maybe who captures value, right? As I mentioned, in PostgreSQL space, enterprise DB is probably not the biggest dog anymore, right? But the cloud vendors have more say. If you look at this single vendor, of course they can say, well, you know what? If we are a company, we are making a business here for our shareholders, and you know what? If the open source interferes with us making the most money, then we'll be open source, right? That's pretty much how it works, right? And we have seen a lot over last few days, last few years, well, now probably more than 5 years, when it started with MongoDB in 2018. But I think now we also have an interesting other trend, and I'm kind of going to talk about that more. If you think about Redis or Elastic here, they change the license to non-open source license, and they can say, well, you know what? It brings its problems, right, with adoption. So maybe we'll kind of go back, or maybe kind of not go back to the same kind of the most liberal open source license, but at least go to some open source license. Let's look why it has been happening. So I just, over the last few days, updated this graph, and this compared their Elastic and open source. What is open source? Well, this is essentially the open source fork of Elastic, right? It's maintained by the Linux Foundation, right? So it's not a single vendor, right? And we can see steadily but slowly it has been gaining the ground, like Elasticsearch was kind of losing the ground per this DB engine standard. Now, what is also interesting in this case, you can see what Elastic was kind of already flattened and stagnated before they changed the license. And we pretty much see that very often, right? If the companies grow, adoption grows like a rocket ship, they don't really need to change the license because they already have a kind of revenue typically growing up pretty quickly as well. It is when the adoption slows down, they can say, well, now it is the time to slaughter some turkeys, right, or monetize our customers, right, and we can change the license in order to force more people to pay, and that's how we can, continue our revenue growth, right. Another graph I'd like to show is this. That's MongoDB versus Postgres. And we can see, right, that at some point in time, there was even this, MongoDB was even kind of more popular by this measure at Postgres, right? But then over last few years, we can see the PostgreSQL is growing and kind of MongoDB in this kind of like a steady decline, right? Not exactly when they change the license, but also when they kind of start to really be very aggressive. Hey guys, you have to go to Atlas. It's going to be very, expensive for you, and so on. And here's also an example of Redis, right? And Redis is kind of interesting, right, because it's changed the license for some components first, and then kind of changed the license for the whole software of Redis, right? After promising they never going to do that, and then they kind of go back again. But then again, still the Redis is kind of in this case have been on decline. Now, something else what is interesting which has been happening recently, all those forks and license change, is in particular interesting in Redis is how quickly the situation changed. In this case, where Linux Foundation supported the fork for Redis called Valky very, very quickly, right? And what I see in this case is kind of the process where things have been accelerated, right? In 2018, when MongoDB changed the license, kind of nothing happened, right? And I think that's really maybe enabled many people to say, hey, you know what, you can just do it, and it works. Then, it's not particularly in the database space, right, but also in open source standpoint. You may have heard about HashiCorp changing the license to Terraform. Anybody heard that? No? Okay. So in that case, it kind of took a few months, right? But in the end, Linux Foundation provided support for like an open TOEFL, right, and some other projects, right? It took time. With Redis, it was like boom, pretty much in a week or 2 weeks. Let's say, hey, here is their announcement and all the forecasts. And what also I think was very cool what they done. They brought a lot of leaders together. Right, like we can see the visual supporters of the Volk initiative, and we can see here AWS and Oracle and Google Cloud. A lot of companies which really compete a lot in the cloud space. They're very fierce competitors, right? But they are all supporting this open source effort of creating Redis Center. And I think that's pretty cool. What Linux Foundation was able to curb the cats in this case. And here at Percona also supported this effort, right? Of course, we are a much smaller organization than those. And last slide I wanted to show you on this matter is anybody, guys, heard about Hadoop? Okay. Anybody uses Hadoop now? Okay, well, and Hadoop is not in the engines, right? But there are a couple of databases which have been based on Hadoop, which is kind of Hive and HBase, right? And I wanted to show this kind of graph about how things die, right? Because your Hadoop reaction was very tepid. It's like, well, you know what? That is something which is just kind of cool, kind of take a placebo, but it's not really very useful, right now, right? And this is how those graph looks, right? And in my opinion, if you look at, the graph of MongoDB, right, or something, it's kind of maybe looking similar to the decline that you can see with those guys, right? Now, note those graphs are all very, right? So if you look at the side here, on the side, so if it's kind of twice declining graph, it's kind of actually much much more than that. Something also very interesting in the databases is what a lot of databases have a long time, right? Especially the large enterprises they deploy, and then something, can be being used for decades, right? So that is why you often say like, oh, it's not like, oh no, in 2 years, right? Technology is not used anymore. Okay, let's kind of move on quickly so I don't run out of time. So if you look at the primary goal, of course, of the license change here, is saying, hey, you know what? We want to create monopoly on database on the, as a service market, right? That is a lot of reasons for the database, right? And why? Well, because database as a service, that is something which is if you run the cloud, that's a state of art simplicity. Right? Hey, you know what? Let's the cloud do all the kind of operational stuff for you, and you can focus just on building your application. That is a very attractive value proposition, right? For a lot of developers, a lot of just focus on what they want to be doing, building an application. But there it also creates a significant problem, right? Because that monopoly in a database as a service, right? That really makes the software not really any different from the open source software. If you are, let's say, a developer who can only use database and cloud, you don't know how to set up all that operations, right? Well, and you, let's say, can only use MongoDB Atlas because of that. Well, how is that different from, for example, Oracle as a proprietary database? There is no real difference, right? And the problem, of course, is if you look at the portion of developers who also have all those kind of operation skills to set up and maintain database, it's kind of getting, less and less those days, right? And I think that will even continue to do so, right? Our AI kind of no-code frameworks, right? And not vibe coding and stuff, right? Then you absolutely have no idea about what is maybe even running under the application you vibed, right? Not even about how to, configure, administer, troubleshoot, and so on and so forth. Now, what also happens here, as it goes to database vendor lock-in, as if any vendor lock-in, it becomes more painful as the time goes, and that kind of lock-in increases. And I think it's very interesting for me is what some of the folks, the companies who've been around for decades, they know that, they remember that very well, right? Now, as a history lesson, do you guys know who this kind of good-looking nice, good-looking young guy here is? Oh, yeah, that's Larry. I never saw it like an initial name of Oracle. And what was Larry doing in his youth? Well, actually, he was saving people from vendor lock-in by a nasty big blue called IBM, right? They have a mainframe and hardware vendor lock-in, and you can say, hey, we'll give you a database with around those kind of small, mini computers, right? Well, obviously, after Larry saved everyone from IBM, what happened next? How many of you would tell Oracle is a company which, save people from vendor lock-in? Okay. And what about this? When you have the lines there, Oracle doesn't have customers, Oracle has hospitals. Each one of them is kind of more reflecting the current state of the Oracle.
So you actually learn lessons from the teachers.
Yeah, so that is I think the problem, right? And the thing with Oracle, of course, right, they built a very serious database. It had a lot of features which it was very hard to migrate from, right? And then they of course could use various practices to make sure you pay them extravagant amount of money. Now, here's something else, which I think is very important about the data in Pariba, right? And what makes data special compared to a lot of the other stuff in our tech infrastructure, right? We often talk about that as the data has kind of gravity, right? It's kind of heavy, it's hard to move around, right? It's also become because that's kind of very sticky. If you have several petabytes of data in some particular database technology, well, it's really hard for you to move, right? It's also kind of tends to attract other things, right? Where the data is, you often going to build other applications around this platform, right? You have to utilize this data, right? And what that means, kind of from my standpoint, right? If you are an organization which cares about saying, I don't want to be at mercy of Oracle, Amazon, right? Other companies like that, you really need to think about how to make sure that you are not locking your data. Use the open source technologies for that. Okay, now let's talk about what has been going on the positive side. Besides all this kind of cloud vendors on one side, is sort of sucking the money from open source ecosystem, and then all those big corporations using that as an excuse to change their licenses to create kind of more lock-in and kind of to lock your data. A lot of situation right now kind of reminds me kind of what we have been in maybe early 2000s. Again, maybe everything reminds me of early 2000s because then that was kind of starting my career. But what I remember was happening at that time is we were there was this kind of pretty well-developed Microsoft ecosystem, right? There was like a lot of tools, there were quite sleek, nice kind of graphical user interfaces, right? And then there was also Linux, like what I would work, and it was kind of much more kind of bare bones, right? You would have to use, less evolved tools, right, and so on and so forth, right? Now, it's similar in what extent. We have on one extent the cloud vendors like Amazon, right, which is a very well integrated, polished, and so on and so forth, right? And then there is the open source implementations in the cloud, a lot of that based on Kubernetes, right? What the cloud native foundation is doing, Zaitsev, right? And it's kind of similar to what we saw with the Linux ecosystem in the time, right? It's not really as much polished or mature. Now, the comparison here to make probably also could be as with operating system, Linux and Solaris. Anybody had experience with Solaris here? Anybody still run Solaris right now? Yeah. Well, for me, that was also interesting experience, right? Because when I was just starting again, late 90s, early 2000s, right? So I have a lot of friends also working with real Unixes. Remember Unixes? Unix kind of thing, right? HQX, AIX, Solaris, right, of course, and that was the real stuff, right? But Linux, what it showed, right? I mean, it doesn't have good support for multiple CPUs, 32-bit at that time, right? It has like a very trivial memory support. You couldn't really get more than 2 gigs of the address space for a single process, right? Which is a very big issue for a database. Well, at the time I was starting, it didn't support file size more than 2 gigabytes, right? So that was kind of a big joke. Well, but look at where the joke that took us, 20 years later, right? All those kind of real Unix operating systems are all but gone, right? And Linux is pretty much dominated. And I think that really shows the power of open source, that is often slow, but steady, which kind of disruptive technology, right? And that is I think similar what we are seeing right now in the cloud ecosystem as well, when we can see more and more choice comes from the cloud native foundation sector, right? Where you can say, well, you know what? The cloud is great, right? And if you look at it, it's a lot of convenience of the cloud is kind of very, programmable, right? But there are different ways we can use it. Here I wanted to show you also this interesting image. And this is an image actually from the old, more than a decade ago, slides of Amazon. You can even see the web service, you can even see the kind of the old logo right there. This is how they have been explaining the cloud to people at that time. And in certain cases they made sense. And well, you know what? For most of us, most of the time, it doesn't make sense to generate our own electricity. Buy electricity from utility, right? Buy as much as you need and focus on, running the stuff, maybe your TV, your microwave, right? Whatever, your computer. Well, the thing about the electricity though, right? I think that is very important. It's kind of highly standardized. Right? It is a commodity. You can buy electricity from multiple different vendors, and if you want, you can run your own. You can put your solar battery, you can run your generator, and you know what? Your TV, your microwave are still going to work, right? How Amazon and many cloud vendors have evolved right now is they don't want, of course, to play in commodity space, because there's not a lot of money in commodity space, right? So they want to move up level and give that kind of a highly differentiated proprietary product, right? And this is, I think, what is important, and how the open source allows you to do is what you can actually choose to run the cloud as a commodity, right? Say, hey, you know what? They're providing me infrastructure, that's great. Maybe Amazon, maybe Google, whatever, right? Or maybe I want to run some stuff on my own data center, but really focus on the open source software to get live. If you look at there are a lot of focus right now is around Kubernetes. Anybody here runs Kubernetes? Anybody heard about Kubernetes? Good, sounds right. And the cool thing about Kubernetes as a technology is universally available, right? It's runs on pretty much any cloud, including managed offerings. You can run it on your laptop, you can run it in your own data center, right, and wherever. And what is interesting with Kubernetes is initially was designed for stateless applications, right? And a database is an always stateless, right? That's where a state is, right? Using that terminology. But actually Kubernetes over the last few years was trying to shave off this idea of that Kubernetes is not for stateless, not for stateless, right? There are and now a lot of work in actually running the data-intensive applications of Kubernetes, right? You can see right this data on Kubernetes community, for example, which does a lot of work on making that possible. We also see the Kubernetes operators now available from most, or at least kind of for most of the popular database systems. So like Postgres has a handful of operators, for example, available. Now, what is Kubernetes, operators, right? And I think why is important, right? If you think about deploying database of Kubernetes, you can actually take, pretty much just container and boom, deploy the Kubernetes. Here I have my database. But of course, that's maybe good to play with it, doing some developments. It's not really something to use for production. The thing in the databases in production, that's what comes from what it means state, right, is what they spend most I provisioned my production database once, and then it may need to live for many years, even kind of maybe decades, where it's kind of staying up. I may need to maintain it, upgrade it, kind of scale it up, or maybe down, but it's expected to stay up all the time, or at least hopefully most of the time. It's not like with my application, right? The application developer, what we do? Oh, you know what's the kind of like application instance may misbehave? What can I do with it? Why don't I kill it in the provision? I don't even think about what's broken out there unless I want to find a problem, right? You know, just destroy it and recreate it is a very easy approach for stateless application, but you cannot do it with production databases. If you just say, hey, you know, I wipe all my data and recreate the database from scratch, and all of that's now so neat and small, your boss probably wouldn't like you. Right? The database, you cannot do that. And that is what Kubernetes operators can do, right? They really have support for all those kind of day two operations, you know, upgrades, maintenance, backup, all you have to do. All right, and I think that is very cool. Right. Well, of course, the Kubernetes operators, they have a different UX, right? Unless you know the Kubernetes, you may find it kind of weird how that all works, right? They don't have really out of the box this kind of, you know, click ops experience, right, that you can get in the Amazon cloud, right? And deploy a database, you know, a couple of clicks, or, you know, press this for backup, press that for restore, right, in this case. But I think what that brings us to the question is, okay, if you have a Kubernetes, can we really build the database on the Kubernetes? Is that a foundation? Well, and I think what is interesting in this case is what it's not really theoretical. You can see a lot of modern database as a service. They are actually built on the Kubernetes underneath. And that works pretty well. It's kind of, you know, pretty experienced, pretty efficient. I can tell like a story specifically about Altinity and the GitHub folks, right? I remember talking to Robert, CEO, and saying, hey guys, you should use Kubernetes here. Oh, but Kubernetes isn't that kind of going to give us humongous overhead if we do that? Well, it turns out, no. If you kind of configure that correctly, it's like a very thin, you know, isolation layer, which is already kind of present in the Linux kernel, right? And you can configure that, you know, pretty well. So that is very commonly used approach right now. I also spoke to one of the guys who have been involved in different database as a service. And then he built those one, I don't know, more than a decade ago. Like, we found this node Kubernetes environment finally, right? And oh my gosh, that's kind of really required for us. Like, so much work if you want to support the new cloud vendor, for example. And in his latest on-prem, you can say, oh, look at that. They built that all on Kubernetes, and that has been very easy for us. We are able to add support for different clouds very effectively. So at least for some people, that works very well. And I'm kind of spending kind of so much time on this because I think there is kind of still a lot of you know, database structures, like database on Kubernetes means death. All right, and I want to tell you, hey, you know what? That works pretty well for at least you know, some people, and there are many millions of the database instances running out there on Kubernetes today. Now, there are a lot of people, of course, building their proprietary things, right, on their base, maybe on Kubernetes or something else, right? And you can say, hey, if I want to really avoid the locking from my data, it doesn't really help me that much, right? What can we do? Is there some open source service? Well, at Percona, we have been last few years building the solution called Everest, right, which allows you to deploy a variety of database on Kubernetes. It has kind of interface similar to the RDS, right, or any other cloud application application, and this is kind of completely open source solution. Now, I think what is also interesting in this case, right? We totally expect, besides Percona, as this open source solutions, start to become more and more popular, probably going to more similar solutions appear in the market, right? And this kind of really lock on the easy-to-use databases by a small number of proprietary vendors probably is going to be lifted. To finish it up, I want to say, I think, in the databases, over the last few years, we have a fantastic innovation. There is a lot of money continuing being invested in the database ecosystem, right? I think there's probably going to more of that coming in, right? As we have this, good acquisitions, as I mentioned, like Neon, for example. That's often says, hey, look at that, we can, make money on databases, on open source databases, nevertheless. So there's probably more money will come out of that ecosystem, right? We can see there is a lot of things still in flux in terms of how exactly the open source of the future in terms of licensing, sort of like governance funding is going to look but I still think that is going to be some very positive future ahead as those questions are going to be resolved. And that's it, all I had, and I even have a couple of minutes for questions if you have any. Thank you. Yes.
Small comment for thanks for the presentation, it was great. Also technically distributed accounting framework in the database. So because the database is comparing other databases, basically how to use basically to marketing framework. I use the extension like SQL, which is not Java, which is querying the existing format, market format, etc. So basically to put, these things like as a database, I think typically it's wrong. Because I have a database, to put like as a database. The HBase is a database, but it's always used for very specific cases and specific communities. How to just technically as a database.
In an HBase.
To put in the slide that is a database, I think.
Well, you can call it like a data store, right? I think if you look at this case, yes, a lot of databases can be more general purpose if there's like more specific, right?
Like the same way that you can write SQL on top of CSV, but it does not make CSV.
No, I understand your point. Okay.
Otherwise, it was
Okay, thank you.
So, any other questions? Okay, Peter, could you switch to slide with separate storage and compute?
Separate storage and compute.
Actually,
Pretty far. Okay, but hey, I want to ask a question about separate storage and compute. Go ahead and ask the question.
I personally strongly disappointed with these trends. Actually, from my point of view, we just chose less efficiency. This scale up, we can better scale up, but we cannot utilize resources because actually in data centers, S3, for example, in Amazon Web Services have limits. Limits inside internal services because disks still disks. We just have abstraction and we have less efficiency and okay, we can scale up, but we cannot scale up infinite.
Yeah, well, look, I think that's a good comment, right? In my opinion, right, I talk about trends, right? I think there are a lot of trends which go against efficiency, right? Like, think about how come you look at your phone, right, and something like a Facebook application takes what? you know. You know, or you think about, you know, something like a Slack you may be using everywhere, right? It's like, oh my gosh, how can it compute so much memory, be so slow on this kind of, you know, the powerful beast that we have right now, right? A lot of things right now, unfortunately, right, or the efficiency is not the first, it's not the first priority, right? But nevertheless, that is the trend to observe.
But yes, scalability to the region.
What's that?
Yes. For this case, like the SQL is basically classical representation what Amazon did and they basically separate computing from the storage on top of the Postgres. And the same for Apache Musa, it's kind of messy system compared to the Kafka. They did separation of the storage and the nodes, basically computing things. And it's not like there are solving efficiency problem, there are solving scalability problem, and it depends on the cases. It can be very right approach for certain cases, but if you are doing high performance computing for trading, probably it's wrong choice, but in the end, so it has its own use cases.
Yeah, I mean, of course, it depends on use cases, right? I think that's when it's people with trends, it's not like, hey, that's, I would not take a trend and say that's everything is going to do this, right? Usually it's kind of multiple solutions that exist at the same time. And I think it's like what I always want to tell people, hey, you know, if you think about the engineering, it's all about the choices and trade-offs. There is no silver bullet. There is no some, you know, like a best programming language for everything, right? Or, you know, best database for everything or something, right? It's all about the trade-offs and choices. Okay, well, with that, thank you, and let us get our next wonderful speaker here. Yeah, we can have a few minutes break while he's sitting down, so if somebody needs to get a coffee